recognition. So, Doc, you want to take it away?
Absolutely. Jim, thank you so much. And to Central Region, Brett Borkhardt for inviting me. It's really great to be here today. Before I pass this off to Rob with the title slide, I want you all to come virtually join me here in South Florida right now. Here's actually a look outside my apartment this morning, and imagine the streets of downtown Miami being flooded with hundreds and thousands and tens of thousands of people as Cardi B and Lady Gaga and Harry Styles and the Super Bowl all come descending upon South Florida right there in the middle of the winter time. And thousands of people are lined up on the streets, but a squall line is approaching the Southeast Florida coast vicinity. It's going to take a lot of time for everyone to get to shelter. And the role of the National Weather Service is vital in terms of having that preparedness and readiness be achieved. It's a huge challenge, and they're not all going to fit in my apartment despite my proximity to the downtown area over here. And so how do we work together to being able to support weather readiness? So I'm going to pass this to Rob Melleda, the Warning Coordination Meteorologist here at the Miami, South Florida National Weather Service Forecast Office, to get us started with solutions to this problem.
Yes, thank you, Ariel, and good morning, everyone. Yeah, I think Ariel set it up really well. Kind of give you a good visual, not just of the nice view from his apartment, but also to kind of set the stage really for what ended up being a very key moment in the IDSS that we provided for the Super Bowl, really about, well, I guess just over 2 months ago. So really, that's so the goal of this presentation is to link the mesoscale or mesoanalysis, if you will, of the weather event the big weather event that we had 2 days before the game, and to tie it into all the things that we do from an IDSS perspective. So as you look through the objectives here, really we're going to be identifying, first of all, some of the challenges in supporting that weather awareness, especially among decision makers. And we're going to make this point several times. Considering the number of people and the number of events that were going on at the same time over a very small area. And when we do that, we're also going to be highlighting the unique needs of those decision makers. It's not just something as simple as receiving a weather alert and then taking action on it. There's a lot that had to happen beforehand in order to make those decisions possible. So those are the areas that I'm going to focus on. Then Ariel's going to really dive deeper into the science, linking, some of the potential solutions, and especially leveraging the physical science of mesoscale analysis, which was key. Well, it's key in everything, everything that we do when it comes to, supporting, and forecasting big weather events, but especially something that's so localized as this particular IDSS event was. And then, of course, the agency, connection, right? What our policy as far as IDSS is concerned, and how this mesoanalysis fits into that. And then we'll get more specific into the actual meteorology of the event, and then really the response to the weather event that we had, basically within 2 days of the game. So with that, I will kick it back over to Ariel, and then he's going to talk a little bit more about at least the first objective.
Fantastic. Thank you so much, Rob. And I want to highlight some of the important concepts that Rob mentioned in terms of the notion of targeted, fine scale, precision. Those are those components of the messaging allow us to be able to speak to individual decision makers, whether or not we're talking to them one-to-one, but when we provide information that's targeted, that's specific, that supports weather readiness at a local, fine-scale detail and resolves the message, that's a much more actionable form of intelligence that we can provide to support effective decision-making. And so we're going to talk about some of the challenges in accomplishing this mission specifically for convective weather within the IDSS paradigm to really provide decision makers with this type of information. So it's very much in line with the Weather Ready Nation concept, the WRN concept. And that's, we're talking about here is providing much more information within that watch warning gap, providing IDSS within that watch warning gap. We're talking about a critical time period between the general outlook and forecasts and when the EAS tones go off. And this is a time period where decision makers, emergency managers, the Miami-Dade County Fair owner, for instance, needs more time than the traditional, 5, 10, 15 minutes for once warning issuance comes out. It takes a lot of time to take thousands and thousands of people out in the streets of downtown Miami and bring them to shelter. And so that target information being provided through a fluid dissemination that is also containing with a level of precision that's needed for local scale decision making, that's a very exciting component of enhancing IDSS. And this concept of bridging the watch warning gap is directly cited within the Central Region Roadmap. And so the Physical Sciences Foundation is to make it come true and really transition our product-centric, rigid type of product schedule-driven dissemination cycle to something that's much more information-centric, service-driven, to account for the decisions that are being made with timescales that go at different levels than just the nominal product suites that we have installed within our legacy product series. And this is very vital for life and property protection. So I'm going to talk about how this fits in, this concept of targeting fluid decision-making type of information, how it's being able to be approached or solved with mesoanalysis. I'm going to talk about 3 branches here for this overall problem in terms of enhancing weather readiness. Not a weather reactive nation, but one that has readiness, one that we're providing more information, more precision, downscaling the message even more strongly. And we're going to talk first about this first component, providing messaging, communication, identifying potential hazards with longer lead time. I'm going to talk about this component, longer lead time, because there are many partners, there are many customers who need more than just the standard warning level lead time up to event occurrence, whereas 30% chance of showers and thunderstorms, a few severe, and 2 to 6 p.m., while that's great to know and it provides some kind of 30,000-foot overview, in terms of speaking directly to decision makers at the local scale, it's very, very broad. It's very general. And there's a lot of messaging that we could be doing between that initial outlook type statement and warning issuance time. And it's bridging that watch warning gap, which is so important for individuals' decision making. This is an example, actually, right, not too long before the Super Bowl, of this concept that we've been employing here at the Miami office with these pre-warning, pre-advisory alerts based on the mesoanalysis that defines the ceiling of potential threat, kind of identifying a reasonable worst case scenario. Even if we're not quite there at confidence levels for warnings and advisories, why can't we get a very targeted message out for our partners in a very specific region so that they have more heads up notice with an identification of the certainty level? Mesoanalysis brings us to that point and is absolutely critical for something like the Super Bowl, where it takes a lot of time and the nominal lead times for our more traditional legacy products aren't quite there. Another component, second component of this mesoanalysis-based weather ready nation and IDSS enhancement is the idea of providing much more specificity, much more precision in the decision support. While it's important that we certainly take the initial background common starting point guidance from our national center partners. For example, this is a marginal risk across parts of South Florida very recently. The reality is that these categories have a lot of variance in terms of what message. Not all marginal risks are all created equally. Some have different levels of potential impact than others. Some have more confidence than others. Some have different timing. There's heterogeneities within the environment, even within the same outlook category, that allow us to be able to provide a much more precise message tailored to our partners and customers within our service area. And this is what allows us component of messaging with the physical sciences foundation of mesoanalysis to break the message down and downscale it into components that speak in a more targeted manner to our partners. For instance, taking this marginal risk area and providing relative levels of threat and precise potential impacts, because there might be some marginals where the ceiling in terms of potential threat is much lower than a more conditionally favorable but lower confidence type of threat. We have the opportunity to downscale the message into different threats, targeting much more local scale, and then identifying reasonable worst case potential hazards. This is a very important concept here in terms of identifying reasonable worst case scenarios. I think there's definitely a long legacy in many components of our agency to start the messaging when our confidence is a certain level. But the reality is that there are many high impact phenomena that sneak up very fast in terms of their predictability. They might be lying within the bounds of a low predictability of high potential impact, but if we wait to start the messaging until it's become much more higher impact or higher confidence level with stronger signatures, that stuff can sneak up very quickly. And for something like our Super Bowl event, where there was a lot of uncertainty exactly how things would evolve, but a reasonable worst case outcome the night before for, within 24 to 48 hours before something much worse happening, that messaging of potential reasonable worst case scenarios is so important. This is very much akin to the storm surge problem, where the messaging, and especially initially, occurs actually at 10% exceedance, because the consequences of not being ready for something that has a very high ceiling of potential impact are deleterious consequences. And so messaging in a conditional, uncertain manner is very important for getting the word out, so that people are not just reacting to a fast accelerating high impact threat that can sneak up on people in a very relatively or conditionally favorable environment. This kind of shows an example of some of that messaging decomposition that we provide to indicate the conditional threats there. And so, I kind of just want to highlight in terms of being able to provide more lead time, more precision in messaging, and identify reasonable worst case scenarios. It's the combination of all of these physical science applications of mesoanalysis to enhancing the message and resolving the fine scale details and building the contingencies into a reasonable worst case scenario versus most likely that allow us to bridge that gap between watch, outlook, forecast, and warning advisory issuance, providing a more continuous flow of precise, accurate information. I give an example here. Say we had at 10 a.m. 20, maybe a standard practice might be 20% chance of showers and thunderstorms today in South Florida. But imagine if we could provide some type of precision. Most of the area will remain dry, but expect a few storms to form in 3 to 5 period, especially over this targeted area of coastal Metro Miami-Dade, along and east of the Turnpike, etc. Storm developments isolated, uncertain, but if it were to occur, these would be the ceiling threats in terms of what the mesoscale environment would support as far as a reasonable worst case scenario. So you need to keep an eye on the sky, etc., and then really provide even more downscale threat assessment at a later time. This is just a really rough example of the importance of being able to speak to individual decision makers without obviously having to talk to every single emergency manager. That's not feasible, especially in some of these very broad metro areas. And so we have the opportunity to apply the mesoanalysis to be able to provide that precision in our messaging, so that there is an implicit direction of the message to influence our partners and customers' decision making. Ultimately, the more precision, the more accuracy, the more of a continuous flow of that target information with the strong physical sciences foundation is the direction to enhancing IDSS. And so I'm going to pass this back to Rob to talk about some of the unique needs for the decision makers across South Florida leading up to the Super Bowl, because there were so many event venues, so many different, parties and gatherings and concerts and going on. And so how do we provide this targeted messaging across our area? And going to talk to Rob, who is absolutely instrumental in running the entire program for developing that awareness and those partnerships leading up to the event.
All right, thanks, Ariel. It's Rob Melleda again. As Ariel mentioned, I'm going to just kind of give a brief background of the basically going all the way back from the planning, from the planning for the IDSS, really all the way up to really about 2 weeks before, which was a critical time. Now, when I say this, I understand that all of your offices have done IDSS and will continue to do IDSS and probably expand it even more. So I'm not pretending that that this is something that's never been done before on the National Weather Service or by any other office. I mean, obviously this is something that we're not only have we been doing for quite a while, but we're going to, like I said, we're going to be doing more and more of, especially for these big events. So a little bit of background. So we started really the planning almost a year before. An event as complicated as, I mean, I shouldn't say complicated, but as complex really as a Super Bowl when it comes to the amount of agencies and the amount of people that are involved. We started really these meetings with city, county, state, federal partners, really just a wide range of partners a year before. Now, the initial meetings were more general. Really, our involvement was it was more just to get a sense of kind of the lay of the land, so to speak, just to get an idea of how things were organized, who's going to run the different operations, and then from there we started to get a picture. Okay, this is where the National Weather Service is going to fit in. So really, in about the final 2 to 3 months, or maybe 2 to 4 months, that's when we really started to get more directly involved in the details with our county emergency management partners, and also some of the state and federal partners that were working with the county already. Then, really, in the last 2 months, the NFL got directly involved as well. In fact, they already had an established link with the county emergency managers and county public safety officials. So they were involved in this as well. Doing all this and having this advanced planning really provided the necessary background information from which we were then able to develop a solid IDSS plan. Okay, yep, next slide should be up already, good. So one of the key components of this was a tabletop exercise that actually we were asked to do by, this was a contractor who worked for the NFL, and then he reached out to me and he wanted us to come up with a weather component for a tabletop exercise that took place about 2.5 weeks before the game, and this exercise involved all the local, state, and federal partners that I referenced. So the weather scenario, when we discussed it, I asked, what are the things that you're looking for? In other words, what kind of components would you like in this scenario? And he mentioned things like lightning, strong winds, even flooding, and certainly those are things that I said, yeah, absolutely. I think those are important. Not only because they're obviously hazards, right, but also because these are things that could easily occur at some point during the event, whether it's the days leading up to the game, or you hope not, but during the game or the day of the game itself. So if you go to the next slide, I think should see. So this was so based on the coordination for the weather scenario, this is what I came up with. And actually, these slides you see here, the slide on the left is the first page, and the one on the right is kind of a supporting graphic. This was from an actual weather event that occurred. It was on December 23rd. It was actually right after we had done the coordination for the exercise. And, so this was based on a real event. Actually, it was a real event. I just basically changed the dates to match the weekend of the Super Bowl. But the point being here is that this is a realistic event. And so basically the main focus in the exercise was not only the threat for severe weather. You see, the area was under a slight risk, but also there was the potential for flooding rains as well. if we go to the next slide, I think that's should be the final one. Yeah, okay, yeah. So like I said, this was based on an actual event. So this wasn't something that we just said, you know what, this is, probably has a almost 0% chance of recurring, but we'll throw it in there as a worst case scenario. Yeah, it's definitely in the spectrum. It is towards the worst case, but it's definitely a reasonable worst case scenario. So if you go to the next slide, that'll be my final one for now. So what are some of the?
Rob,
Yes. Oh, can you go to the next slide?
Is it just me, or is Rob's voice cutting out?
Can you hear me?
Yeah, I can hear him just fine.
Okay.
Yep.
Okay. Yeah. I see that. Looks like the slide's not transitioning. It's not going to the next one. It looks like it's frozen.
Yeah, it looks like your slides are frozen, Doc.
Okay. Well, that's okay. While we get that figured out, some of the lessons that we learned from taking part in the exercise and coordinating that weather scenario was, where there were some pretty important things. One of them was the wind speed thresholds for a lot of the tents that were going to be placed, not just at the stadium. In other words, in the parking lot and right around the stadium, there would be lots of tents where they were going to have events. Also for staging for people that were entering the stadium, for ID checks and things like that. But also the areas where a lot of the events were occurring downtown. You saw the picture from Ariel's apartment there. A lot of those areas are prone to flooding from even really rainfall rates that may not seem terribly excessive for most areas. So, these areas need extra lead time when it comes to flooding and also for wind. The amount of lead time required more than the normal, and I think Ariel kind of referred to it earlier, for the vast amount of events that were occurring and in the days leading up to the game. So it's not just the game itself, the game day itself, but all the events that were going on in the downtown Miami area. Basically, in that picture that Ariel sent, that Ariel showed at the beginning, that's really where I'd say, about maybe 70 to 80% of the events occurred right within that maybe two square mile area roughly. And then this is probably the key, probably the most important thing actually that we learned from this exercise, which really paid dividends during the event itself, was we realized that we needed to consider, or actually we needed to schedule additional deployment of forecasters to not just the county EOC, which had already been set up, but also to the city of Miami EOC. These are separate entities. And,
hey, I'm sorry to interrupt. I went completely dead on my internet for the last 3 minutes. Where are we? I am sorry.
We're in slide 15. Yeah, there you go. That's
okay,
it.
wonderful.
Yeah, in fact,
okay, I've been kind of wondering what's going on. All
okay,
right.
yeah, so yeah, I'm almost done. Yeah, I was on the last point here.
You just cut out completely. Sorry, keep going.
No, that's okay. Thank you. Yeah, like I said, the need for additional deployments to support not just the county, which is obviously a larger entity, but the city of Miami EOC itself within the county, which is where most of these events were occurring. So we hadn't planned that initially, thinking that the county was going to handle all the coordination and all of the information dissemination to the cities within the county. But the city reached out and said, look, we got all these events going on. I understand the what you have planned with the county, but we would really like it if you would have somebody at our EOC so that we had that direct link to you instead of having to rely on a secondary form of communication, if you will, or getting information not directly from us, but from the county to the city. So that, like I said, we'll talk about that in more detail towards the end, but that was probably the most important lesson, the most important thing that we were able to do, or adjustment that we were able to make to our plan. Really just a short time, 2.5 weeks before the event itself. All right, Ariel, I'll go ahead and kick it back over to you to get into more of the mesoanalysis.
All right, thank you. Apparently, I'm running into some bizarre internet issues here. You sounded like a robot and then cut out for a couple minutes. And so I apologize if we run into that again. So we're going to talk about how the solution to a lot of the challenges that Rob had laid out, and just in general in terms of the messaging for Super Bowl or other large event venue type of circumstances, is very much complemented and supported by the concept of mesoanalysis. And then talk about some of the agency-wide initiatives in mesoanalysis for enhancing IDSS, what they have been, and how they can be applied to really enhancing that for the Super Bowl. And so again, kind of summarizing the three primary opportunities that we can leverage from the concept of mesoanalysis is enhancing lead times beyond legacy product suites in terms of the messaging, continuous flow of information leading up to event occurrence, which requires some knowledge or at least some insight as to what will the radar look like in an hour from now, 2 hours from now, 3 hours from now. How about worst case scenarios? What might be most likely might not be the reasonable worst case scenario that can be supported as a ceiling in terms of potential impact by the environment. And that's important to be considering. What can the local environment actually support at individual locations? How does the heterogeneities in the density fields across the region of the mesoscale potentially influence that targeted type of impact that we can communicate? It could be very different than just the larger threat area, broader threat area. And all of these factors are governed by and controlled by the storm environment and the heterogeneities there in the mesoscale environment. I can provide a couple examples of actually from my old office there at the Topeka Forecast Office of providing that continuous flow information, even if a most likely scenario might be not much in the way of damaging weather, a reasonable worst case scenario might be something that's much worse than we can provide that uncertainty but potential outcome so that people are ready. And for something like the Super Bowl, that time, that lead time for potential threats is so vital to having people be ready to transition from something like this to something like this, and not be caught off guard. After all, the message is going to also vary significantly, even within the same categorical delineation. That is, this is an example of an outlook just kind of talking about how the messaging needs to be downscaled from the outlook in this sense that these are two marginal risk areas. One is over Arizona, Mogollon rim convection, weak shear environment, high confidence in storms, a few pulse swept microbursts, whereas a marginal risk up here in North Dakota would be characterized by high potential impact, but very low confidence in storm development. It's a very different message between the marginal areas and a very different response level needed in terms of what our partners and customers need to be doing, kind of illustrating the probability density function of potential outcomes for Arizona, showing a relatively high confidence, high probability peak in a lower impact zone compared to the North Dakota marginal risk area, where there's more higher, I should say, probabilities for worse, for higher impact types of scenarios, and lesser certainty, resulting in the peak of that distribution being lower compared to that in Arizona. But then the time as leading up to event occurrence in North Dakota will result in the shift of that mode of the distribution towards a higher impact category, whereas that for Arizona stays the same as the upper reaches or the ceiling of potential impacts is not as high given the weaker shear in that environment. And so the messaging can be provided accordingly. This is something that Operations Proving Ground has invested in. Been very, very fortunate to have worked with Kim Runk and many others at the OPG, and many individuals who were brought on to the initial think tank, Mesoanalyst think tank initiative that then brought into the Mesoanalyst boot camp that essentially established a foundation for developing extensive training materials, exercises, drills, publications, AWIPS procedures, templates into being able to apply this targeted threat assessment, leveraging the deep physical sciences. And some of the takeaways from this endeavor run by the OPG and involving many individuals across the agency, many of these values being integrated into the Central Region Roadmap are also laid out here in the executive report highlighting the need for mesoanalysis and shifting this mindset and overall targeted threat assessment to one that leverages physical science to support that precise messaging with more lead time and a much more disaggregated, downscaled approach, taking the physical sciences R2O, O2R types of feedbacks. This is very relevant to being able to provide a much more enhanced version of our services. Applying the deep physical sciences to identifying what's a reasonable worst case scenario from what the mesoscale environment would actually support. And also ultimately merging that with communications expertise, providing messaging. These are examples of Rob Melleda providing the communication of leading up to Irma, I believe, to EOC across that area, so that we can take a broader threat area and target specific regions where the heterogeneities in the environment are going to support differences in the level of impacts that could speak more directly to local emergency managers and decision makers, and then communicate that, build credibility, identify reasonable worst case scenarios, contingencies based upon what the environment can support in technical discussions by taking a broader area and really looking at the fine scale details, for example. Ultimately, I know we're kind of running out of time, so I'm going to go relatively quickly through what led up to the event at the evening, couple evenings before the Super Bowl, kind of in a very similar pattern to what we saw with the case exercise. We had a broad warm advective corridor that lay in advance of a positively tilted mid-level cyclonic perturbation across the southern Great Plains vicinity with strong mid-level winds, encouraging an adequate deep shear for organized convection amid a broad warm advective corridor of gradually increasing low-level moisture. Here in South Florida, it seems like the really rich moisture is never too far away, and so with that northward poleward percolation as the broader poleward mass flux to that disturbance submerging over the western Gulf of Mexico eventually allowed the aggregation of convective plumes over the eastern Gulf of Mexico in the vicinity of this frontal this diffuse baroclinic frontal zone to support general upscale growth and the development of a squall line. And I believe that these slides, yes, I think Rob had put this in. Rob, as you can see, the outlook leading up to our actual pre-Super Bowl, a couple nights before Super Bowl event, when there are a lot of parties going on there heading into the weekend time frame. Very similar area to what was practiced upon, very similar initial messaging in our DSS package to our partners. While this was not the actual Super Bowl itself, but the day before, kind of looking into the evening or two before, we were able to have potential for a lot of high impact weather affect the area that we had practiced on. Severe thunderstorm watch was issued by the Storm Prediction Center with a slight risk being driven by both tornado and wind probabilities as well. And we were able to very much leverage these concepts, providing pre-alert, I should say, pre-WAWA, pre-warning advisory messaging. You can see this is Harry Weinman here putting a long lead time graphic out in western Miami-Dade County as convection was just coming off the Gulf waters, providing that heads up awareness at a targeted level before we even were issuing any formal warnings or advisories at all. I'm working on radar over here. This is our TDY, Laren Reynolds, who's helping out with some of the messaging as well as SPSs. This was definitely a whole office concept endeavor here, where we're really being able to provide that targeted information with much more lead time and the time unlocked by leveraging model blends so that we're able to spend more time on the detailed analysis, letting automatable components of the forecast process take over when they can provide that level of value, so the meteorologists provide that nowcast, that very detailed threat assessment in the here and now, so that people can stay safe across Miami proper. Ultimately, this was a very intense squall line. We actually had TDS in mainland Monroe County. I think one of the first ever TDS determined remote surveys of some sort that this office had done. Rob, correct me if I'm wrong, but you can see this was definitely what had tracked across far South Florida within a moderately sheared environment and boosted inflow region effective storm relative velocity. a very much balanced cold pool shear balanced regime, both offered by the low-level shear cold pool balance as well as the deep shear, supporting efficient updraft generation through deeper layer forcing, even rising above the cold pool. Being able to provide that targeted threat assessment, pre-warning SPSs, warnings long before the approach or entrance of the system. Ultimately, Rob, if you want to kind of summarize a few of the comments here with me as well, you can see this is a log highlighting over 30 different briefings provided the Friday before the Super Bowl, leading up to the development or approach of the storms. Both Molly Merrifield as well as Robert Garcia at our office providing just very frequent fluid information leading from the outlook phase up to event occurrence, talking to emergency managers across the city, Miami-Dade County, so that the continuous flow of target information between nominal, more rigid benchmarks and product cycles was absolutely critical to supporting readiness. Rob, anything you wanted to mention here?
Yeah, just to point out a couple of things, especially when it in regards to the coordination between our on-site meteorologist Molly Merrifield, who was at the Miami EOC. She was, of course, there coordinating directly with the city decision makers, and the city was asking, questions about timing, of course. What were the chances of the event occurring? What the hazards would be? What the hazards would be, and then if a watch would be issued, what kind of watch? Because what ended up happening was they decided to basically start canceling events once a watch was issued. So in other words, they weren't going to wait. They were going to put the vendors or the event organizers on notice, basically, when a watch was issued. But really strongly considering at that point the cancellation of the events at the onset of at the issuance of the watch. So the watch was issued around 8 p.m. around little bit I'd say about 3.5 hours before the line of storms moved through. So the Miami emergency managers sent a notification to all the outdoor vendors recommending that they cancel the events due to the severe thunderstorm watch being issued. Now, as it turned out, most of the vendors did choose to cancel at that point. Now, they also said that if the warning is issued, then the cancellations were mandatory. In other words, they would become mandatory, not just a strong recommendation. And sure enough, I would say about an hour. It was almost an hour before the line moved through. That's when the warning was issued. Now, normally we wouldn't issue a warning with that much lead time. However, in this case, since we knew the sensitivities of the event and the number of people, the number of events that were going on downtown, that early notification, first of all with the SPS beforehand, and then with the actual severe thunderstorm warning, that made the decision that much easier, of course. And it gave the emergency managers that leverage that they needed to cancel these events, and that's really basically what happened. I think if you go to the next slide.
And I just want to highlight,
go ahead.
In terms of having the confidence to being able to issue it with this untraditional lead times and have that information out there, it's not just a random shot in the dark. We're applying the 3 ingredients methodology, the deep shear consideration and its orientation to the line, the environment, inflow region characteristics. We're combining this very targeted science-based threat assessment to enhancing that service relative to what the partners need, as Rob had talked about. So Rob, go back to you.
Yeah. So this is a compilation of some social media pictures and articles about the events that were canceled and some of the impacts. Fortunately, we didn't have damaging winds. The winds probably got up to about 45, maybe up to 50 miles an hour. Nothing really more than that, fortunately. However, we had heavy rain in a very short period of time in those flood-prone areas, which we talked about earlier. So some of these temporary venues that were set up, they were basically like these temporary facilities that were put up where these concerts were occurring. Water got into a couple of them. You see some of the pictures, especially in the left-hand side of the screen there. Harry Styles canceled. Well, the event organizers canceled the concert, but they actually canceled it pretty late. They were, I think, one of the last ones to cancel. I'm sure there was, a lot of pressure, a lot of people that were already there. But basically, the fire department, as you see there on his tweet in the lower right, he sent out a tweet himself saying basically the fire department forced them to cancel it, even though I think the event organizers really wanted it to go on. So, as much as the city can get the word out, it's really up to the individual events and the event organizers to do the right thing. And for the most part, they did. But, there were a couple that really wanted to wait to the last second, and unfortunately, although there were no ramifications because of it, people were kind of wandering around. The people that were at the Harry Styles concert, they were wandering around afterwards, leaving the venue in these flood waters, and it was still raining, or there may have even still been some lightning, maybe that was from the back edge of the storms. So, it definitely wasn't the ideal circumstance as far as in that particular venue there. But again, just kind of to summarize everything here before we go to the last slide, it's not just the planning ahead of time, but the close coordination in the hours leading up to the event that really helped us to deliver this entire package, basically, from Ariel's Mesoanalysis or focus to the products that we were issuing in the hours leading up to the event, to the actual delivery of the watch and eventually the warning during the event. So anyway, I don't want to belabor this anymore. So Ariel, if you want to go ahead and conclude it with the next slide.
It was good to see, when Capital Weather Gang wrote up the article on what had happened, it was good to see when they were taking some of the actual targeted messaging that we had provided here, kind of the pre-alert, the pre-warning alert concept, and building them into the actual article as a service enhancement. And yes, this is something we had no control over, but yeah, apparently we heard real time about Lady Gaga's costumes and wigs being destroyed by the flood. That's something that I guess that they were not preparing for, and so in the future, hopefully they'll be ready after that incident. Ultimately, the feedback from partners was absolutely stellar as far as providing this continuous flow of information, highlighting Molly as well as Robert's work in keeping everyone informed, providing that conduit between the forecast office and the partners. Ultimately, I'll leave it at this slide in case Rob, I know we're absolutely out of time here. Really just kind of reiterating the 3 points about enhancing the lead time of impact messaging, breaking down, downscaling the threat much more to targeted levels that really speak to the threats individually tailored across this broader event venue type of service that we're trying to tailor our messaging to, and then identifying reasonable worst case outcomes, which in this particular case, while Mesovortex did not go right over the Super Bowl, we did have Mesovortices farther to the west, one that it did produce a TDS in mainland Monroe County, and watching that aimed at Southeast Coast was definitely something that we responded to accordingly. So, Rob, is there anything else you wanted to mention? Ultimately, these are tenets for going from a reactive nation to a ready nation, and that's what we're trying to highlight here as applied to the Super Bowl.
No, I have nothing to add. I just want to say thank you to Central Region for hosting us and for giving us the opportunity to present our experiences with the IDSS for the Super Bowl and the Mesoanalysis that was involved with the